All right, guys, this is where we left off yesterday with these here. 54 or 53? We have 55. Which one of these do we want to look at? 53. So we have sine of x plus pi over 6 minus sine of x minus 7 pi over 6 is equal to the square root of 3 over 2. So this first one here, sine of x plus pi over 6, is a sum identity. And we can replace it with its equation. So sine of x plus pi over 6 is the same as sine of x cosine of pi over 6 plus cosine of x sine of pi over 6. Now we can have that in parentheses because that is one set term, but since there's not a sign in front of it, it really doesn't make a difference. Minus. Now because we do have subtraction of our next difference identity, we will need parentheses around it. Now sine of x minus 7 pi over 6 is going to be sine of x cosine of 7 pi over 6 minus cosine of x sine 7 pi over 6 is equal to the square root of 3 over 2. So the first thing we did is just applied these angle properties, or these trigonometric identities. Now we can do some simplifying. And in the first one, we have cosine of pi over 6. That has a specific value. Cosine of pi over 6 is square root 3 over 2. So we have square root 3 over 2 times sine of x. Plus, sine of pi over 6 is 1/2. So we have square root 3 over 2 sine of x plus 1/2 cosine of x minus cosine of 7 pi over 6 is negative square root 3 over 2. So negative square root 3 over 2 sine of x. Sine of 7 pi over 6 is going to be negative 1/2 times cosine of x. But here our negative and negative would make a positive. And this here is equal to square root 3 over 2. Now at this point here, we can start simplifying these parentheses away. So the first two terms are just going to end up being the same. Since there is no sign in front of this first set of parentheses, we can just drop them there. Now the second set, we do have to distribute this negative through, which is going to turn our negative square root 3 over 2 sine of x to positive square root 3 over 2 sine of x. And our positive 1/2 cosine is now going to become negative 1/2 cosine of x is equal to square root 3 over 2. Now this here, 1/2 cosine of x and negative 1/2 cosine of x are like terms, and when we combine them, they become 0. Our other like terms are these two here, square root 3 over 2 sine of x plus square root 3 over 2 sine of x. So really what we're adding is square root 3 over 2 plus square root 3 over 2, which is just going to be the square root of 3. Sine of x is equal to square root 3 over 2. Questions on this here? And it is interesting in trigonometry, or some of the math problems that we solve, where it starts out at a decent length, it gets bigger, and then all of a sudden gets smaller. Now at this point here, we need to get sine of x by itself. So the next thing we can do is divide both sides by the square root of 3. So this here will give us sine of x, because our square root of 3 divided by square root of 3 would be 1. Now we do need to take the square root of 3 over 2 and divide it by the square root of 3, which will give us 1/2. Telling us that sine of x is equal to 1/2. Now at this point here, we can look at the unit circle, and we're trying to see where sine is positive 1/2, which is pi over 6. And the other spot where it's positive 1/2 is 5 pi over 6. And that's it. Any other question or any questions on this here? Any other questions on 53 through 55? One of those that y'all want to look at. Right. 56 through 59. Huh? Yeah. There's nothing of that difficulty that does show up. All right. Let's look at 60 through 62. Rewrite each expression using the double angle formulas. So we have these three here. So for this here, we're going to be looking at the double angle formulas. So we're going back to sine, cosine, or tangent, just a single term. Now, sine of x, cosine of x. This here is similar to our sine of 2x, which is equal to 2 sine of x times cosine of x, because this is the double angle formula that it's closest to. But they're not the exact same, because what we have is sine times cosine. And here we just have, so what's this have that this is missing? The 2. So really, to get them to be the same, I need to divide this by 2 so that they are the same. Because here the 2 divided by 2 is 1, telling me that sine of x times cosine of x is sine of 2x over 2. So using the double angle formula, sine times cosine of x is our sine of 2x over 2, or it's the same as saying 1/2 sine of 2x. Both of those are the same answer. And that's it. So all we're doing is manipulating the formula to match what they gave us in the other form. Questions on this first one here? If we look at this next one, 61, cosine squared of x minus 1/2. Out of all the double angle formulas, there's only one that has cosine squared, and that's our cosine of 2x. Because cosine of 2x is equal to, there's several, but 2 cosine squared of x minus 1. And the reason we're going to use this one here is because there is no sine squared, because cosine of 2x is equal to cosine squared minus sine squared, or cosine of 2x is equal to cosine squared minus 1, or the other one, cosine of 2x is equal to 1 minus 2 sine squared. This one here is the only one that has cosine squared, and since we don't have sine, we're looking at this here. Now, this cosine doesn't have what? But this one does. 2. So how could we get rid of that 2? We can divide by 2. But if we do, we have to divide everything by 2. Well, 2 cosine squared divided by 2 is cosine squared of x. 1 divided by 2 is a half. So in this, well, it's just cosine of 2x over 2, or 1/2 cosine of 2x. Because again, we're just manipulating that equation in the general form to match what was given. And what we have on the other side is our answer. Okay. Questions on 60 or 61? '62. The only one that does have sine squared by itself with our double angles as well. Cosine of 2x is equal to 1 minus sine squared of x. Only one that has sine squared. But there's a few things that are different between what they have to begin with in this general form. And sorry, there should be 2. Because our negative 2 sine squared is positive 10 sine squared. How can we change the negative 2 to positive 10? Yeah. Because if I multiply this whole side by negative 5, let's see what we get. Negative 5 times negative 2 sine squared. Well, negative 5 times negative 2 is positive 10. We still have the sine squared of x. And negative 5 times positive 1 is negative 5. Does that now line up with what we started with? Well, yeah. And what we do to one side, we have to do to the other. So we'd have negative 5 cosine of 2x. And that's our answer, negative 5 cosine of 2x. Because we're manipulating the one side of the equation to get what they gave us. And as we manipulate that side, we have to manipulate the other to make sure that it's still equal. And that other side is our answer. Questions on this here? All right. '63 or '64, which one do we want to look at? '63. For problems 63 to 64, find the exact value of sine of 2 theta, cosine of 2 theta, tangent of 2 theta. And we're told that cosine is negative 4/5. And our angle is between pi over 2 and pi. So if it's between pi over 2 and pi, we're over here in the second quadrant for our angle theta. So we're going to set a triangle up. Cosine is adjacent over the hypotenuse. And our other side is going to be 3, because it's a 3, 4, 5 right triangle. If it's not a 3, 4, 5, we can use Pythagorean's theorem to get the other side. Now, part of the reason we need this triangle is to help us find the values of sine, cosine, and tangent to find our answers. Because the first trig function it wants us to find the exact value of is sine of 2 theta. And according to the theorem, sine of 2 theta is equal to 2 sine of theta times cosine of theta. Well, the problem told us cosine of theta is negative 4/5. It didn't give us sine of theta. But we can get it from the triangle, because it'd be opposite over the hypotenuse, which is 3/5. And now we just need to multiply these together, because 3/5 times negative 4/5 is negative 12/5 times 2 is negative 24/25. And that's our sine of 2 theta. Questions on how we found sine of 2 theta? Cosine of 2 theta. We have several different options. Well, I'll just start with the top one. Cosine squared of theta minus sine squared of theta. Now we know cosine of theta is negative 4/5. Sine of theta is 3/5. Now if we square these, 4/5 squared is going to be 16/25. And 3/5 squared is going to be 9/25, which will tell us that this is 7/25. Questions on how we found cosine? We feel good with this here. Now there are other equations with cosine, because we could have said 2 cosine squared of theta minus 1, which would have been 2 times negative 4/5 squared minus 1. You don't necessarily have to write this, because it'd be 2 times 16/25 minus 1. Well, that'd be 32/25. And if we subtract 1 from it, we get the exact same answer. Or we could have done 1 minus 2 sine squared of theta, which would have been 1 minus 2 times positive 3/5 squared. And at this point here, really for this problem, we could type that into the 30xs, either calculator, and get our answer. That'd be 1 minus 2 times 9/25, which is 1 minus 18/25, which is still 7/25. So no matter which equation we use for this here, we will still get the same answer. We just have to pick one of those and do that there. Now the last one we need to find is tangent. Now tangent of 2 theta is equal to 2 tangent of theta over 1 minus tangent squared of theta. We have this here. But tangent is what also? Tangent is just sine over cosine, because we could use this formula, or I can just say tangent of 2 theta is equal to sine of 2 theta over cosine of 2 theta. And we already found sine. Sine is 5. And cosine is 7/25. And at this point here, we just need to type this in, which will tell us that tangent of 2 theta is negative 24/7. Tangent's going to be 3 over negative 4. Because if we did the formula, the numerator is going to be negative 3 halves. Denominator is going to be 1 minus 9/16. We'd have negative 3 halves over 7/16. 7 on bottom. Negative 24 on top. We get to the exact same place. It's just picking which one we want to use. Any questions on 63 or 64? All right. Questions on 67 through 69? Well, that's just calculator, because I can plug in sine of 165, cosine of 165, and tangent of 165, and it'll give us our answer. But do make sure, especially for 67, 68, 67 is in degrees, 68 is in radians. If you have it in the wrong mode, it will give you the wrong answer.
But wouldn't it give you like a zero, like a weird number, so you know it's like...
Probably, yeah. Yeah, because 165, it will give you radicals, especially if you plug it in the graphing calculator, it will give you a decimal no matter which one you pick. Because 165 is going to be one of our angle sums, because it'd be 135 plus 30 for sine, cosine, tangent, so we'd be using angle sum, but it'll still give you the answer. It's just sine 165, cosine 165, tangent. We get these here. The graphing calculator would give you decimals, but yes, it should kind of throw things off. If it has pi, it's in radians. If it has our little degree symbol, it's in degrees. Yeah. Question on 72 or 73? 72. Sine of x plus y times cosine of x minus y. This here is our product to sum identity. Sine comes first, cosine comes second. So this would be matching up to sine of alpha cosine beta. Because we can do it this way, is equal to 1/2 sine of alpha plus beta plus sine of alpha minus beta. Well, alpha is x plus y, beta is x minus y. So if we do this here, we'd have 1/2 of sine of x plus y plus x minus y plus sine of x plus y minus x minus y. Here, there. Here, there. Yep. Now we are going to need to simplify, especially inside these parentheses. Because here we really have x plus y plus x minus y. Didn't need that extra parenthesis. Plus sine of x plus y minus x plus y. Well, x plus x is 2x. and our y minus y become 0 plus sine x minus x this time become 0, and our y plus y is 2y. Rewrite as product to sum or sum to product. So it started out as a product and it ended up as a sum. Sum or difference. Yep. But again, that's our product to sum, sum to product on the reference sheet. We just matched it up and plugged it in. Now the next one is a sum. So our answer we want to be a product. Cosine of alpha plus cosine of beta is equal to 2 cosine of alpha plus beta over 2 times cosine of alpha minus beta over 2. Now for us here, alpha is x, beta is 4x. So we'd have x plus 4x over 2 times cosine of x minus 4x over 2. X plus 4x is 5x over 2, and x minus 4x is negative 3x over 2. And that's it. Questions on 72 or 73? You can come back later. Jonathan, you can come back later. Questions on this here? All right. 74 and 75, how can we do these here? Yeah, calculator. Yep. We can just stick those in the calculator and they do them for us. I mean, the other way is just using the unit circle, because sine of 5 pi over 4, negative square root 2 over 2, 3 pi over 4 for sine square root 3 over 2, telling us that we have negative square root 2 minus square root 3 all over 2, but the calculator will do these for us. And that's it.